In this video, we're going to focus on the connective, the implication. Okay, this is a conditional connective, and it's something you've encountered many times in your life. So your mother might have said, if you eat all your vegetables, then you can have dessert. Okay, this is an implication. Okay, if you eat all your vegetables, then you get dessert. Now, if your mother said that to you, and you did eat all your vegetables, you would definitely expect to get dessert. But if you did not finish your vegetables, then you would not complain if you got dessert, but you're not expecting it because you didn't finish your vegetables. Okay, so this is sort of the idea behind the implication and when it's true. So the implication, remember, is written P arrow Q. Okay, P is called the hypothesis or premise, and Q is called the conclusion. Okay, there's different ways. There's several ways to write or read an implication. So the most common is if P, then Q. But you could also say P implies Q. Okay, or you could say Q if P. Or you could say P only if Q. Or you could say P is sufficient for Q. Or you could say Q is necessary for P. Okay, there's probably more, but those are the main ones that you see. Notice that occasionally the Q is first. Okay, so P implies Q is common. Q if P, so you still, P is after the if. Okay, so Q happens if P happens. Okay, now P happens only if Q happens. So that means, so if you think about the if P then Q, so this happens, that guarantees that this is going to happen, right? Only if. What does the truth table look like for this? So again, we have the two variables. So that's my two columns. Should make these a bit longer. Okay, so same as before. Okay, so those are all the possible scenarios. And then we have P implies Q. So let's talk about these in regards to the vegetable example. So if you ate your vegetables, so that's the P. Okay, so if that's true, you definitely want dessert. Okay, so if that happens, then your mom did not break her promise. Okay, so you ate your vegetables and you got dessert after. Okay, so this implication is true. I'm going to skip this one for a second. Let's think about, what if I did not eat my vegetables? Okay, so if I did not eat my vegetables and I did not get dessert, my mom did not break her promise, right? So I didn't eat them. So she said, if you eat your vegetables, then you get dessert. So I'm not expecting dessert if I don't eat my vegetables. And then when I don't get it, I'm not mad at her because I know that I did not eat the vegetables. Okay, now this is the one that people maybe find confusing. So I did not eat my vegetables, but I still got dessert. Okay, so my mom did not break her promise here either, because she said, if you eat your vegetables, then you'll get dessert. So the premise needs to happen in order for the conclusion to mean anything. So if I did not eat the vegetables, I may or may not get dessert. I'm not really sure. Okay, if I eat my vegetables, then I'm definitely getting dessert. Okay, but if I don't, then I don't really know. So this is still true. Okay, so I'm just going to write, there's no promise here broken. Okay, this is the only instance where it's false. Okay, so the premise is true, but the conclusion is false. So that means if you think about the vegetables, I did eat my vegetables, but I did not get dessert. So if you're the kid there, you're going to be pretty mad. Okay, because your mom broke her promise there. So that's the only time that it's false. So let's just determine the hypothesis and the conclusion here. So you're in Canada if you are in British Columbia. Okay, so the hypothesis is the P. The conclusion is the Q. So we see this word if. Okay, so the thing that follows the if is the hypothesis. Okay, so you are in British Columbia is the hypothesis, which means you are in Canada is the conclusion. Okay, now Bill goes to the party only if Greta goes to the party. Now this one is an only if. Okay, so that's a bit different. So I'm not going to write hypothesis. So the premise is actually Bill goes to the party. And the conclusion is Greta goes in this instance. So you might be thinking, but there's an if here. Shouldn't that be the premise? Okay, this says only if. So that means Bill, you'll only see Bill at the party if Greta's also at the party. Okay, so if you think about, so Bill going to the party guarantees that Greta's going to be there because otherwise he would not have gone. So that means if Bill goes to the party, then Greta must be at the party because that's the only way that he would have gone. Okay, so that's why Bill going to the party is the premise here. Okay, now here we want to determine whether these statements are true or false, and I hopefully picked things that you know the truth values for. So the premise in the first one, so if 3 is odd, then 3 squared is even. Okay, so that means 3, the premise is 3 is odd, and the conclusion is 3 squared is even. Okay, now hopefully we know that 3 is in fact an odd number. Okay, but 3 squared, that's 9. 9 is an odd number, not an even number. So this Q has the truth value false. Okay, so that means that P implies Q, or if P then Q, is going to be false here. Because I have the premise is true, but the conclusion is false. Okay, so that's when I get a false. Okay, now here in the next one, it says 2 plus 3 equals 5 if Regina is the capital of Canada. Okay, so the if, it's not an only if, it's an if. Okay, so my premise is Regina is the capital of Canada. And my Q is this math equation, 2 plus 3 equals 5. Okay, so Regina is not the capital of Canada, so that is false. 2 plus 3 does in fact equal 5. So here, the premise is false. The conclusion is true. So what do we say about the implication? Okay, it actually doesn't matter that this is true or not. The premise being false guarantees that the implication is true. Okay, because the implication says if P happens, then Q must happen. Okay, but if P doesn't happen, then it's sort of, we call it vacuously true. It's just true automatically because there's no way to break my promise in that instance. Okay, let's try another example. So here is a compound statement. So I have the or and an implication. I'm going to make my truth table so I only see P's and Q's. Okay, so true, true, false, false, true, false, true, false. So I'm going to build up. So I'm going to do P or Q first. Okay, so we remember that this is true, or this is false only when they're both false. So it's going to be false here and true everywhere else. And now P or Q implies P, so the full statement is this is the premise, this is the conclusion. So true implies true, that's true. Okay, true implies true, that's true. True and then a false, okay, that's where it's false. So when the premise is true, but the conclusion is false. Down here I have false implies false. So when the premise is false, I get true automatically. Okay, so that would be my truth table here. Okay, now another one where we have three variables. Okay, so I have a P, a Q, and an R. So that means I'm going to have three variable row or columns. And I'm going to have more than 4 rows. I'm going to have, in fact, 8 rows. Okay, I think I have enough there. So the way that I like to set it up is I do split the rows into half. So the first half are when P is true, and the second half is when, P is false. Okay, and then for each of these halves, okay, I'm going to split it in half, and I'm going to have Q true and Q false. So why did I do that? So why do I have 2 rows where P and Q are both true? Is because R could be true or false there. So then I have 2 rows where P is true, Q is false, and then R could be true or false. Okay, so that's how I like to do it. So then similarly split this in half, so 2 trues, 2 falses, and then true, false, true, false. So you want to make sure that you have all different truth, every different truth assignment exactly once. Okay, so all trues, only R false, only Q false, both R and Q false. Okay, only P false, only Q is true, only R is true, and they're all false. So these are all different. Okay, and now I'm trying to build up to this. So like I said, I like to build it up. You could do it all at once if you want and just go underneath. So I would do not P, because I need a not P in there. So that's the opposite. So that's going to be false, 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 true, 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 true. Okay, and then I want not P and Q. Okay, so not P and Q, I'm looking at column 4 and 2, and I want them both to be true. So here, not P is, so in the first 4, not P is false. So the first 4 are going to be false. And then the next 4, not P is true, so I just want to look where is Q true, and that's going to be these first 2. So that's where they're both true, and then over here Q is false. Okay, I also need R implies P. Okay, so now I'm looking at R and P. So when R is true, I need P to be true. Okay, so that's true. In the next, so every other row, R is false, which means that the implication is true automatically. Okay, in the third row, I have them both true. So that's true. And then in these last 2, R is true, but P is false. So that's exactly where the implication is false. Okay, and then finally, I want to put these 2 together. Implies R implies P. Okay, so here I'm looking at this. This is my premise column, and this is my conclusion column. So anytime the premise is false, okay, this thing is true automatically. So also down here, the premise is false. And then these 2 rows where it's true, in one of them it's true, true, so that's true. But in the other one, it's true, false. And that's the only time that we get a false for the implication. Okay, now is the order that they're written important? So essentially, is P arrow Q the same as Q arrow P? Right? Well, okay, so the answer is no, because the premise is very important. So if the premise is false, then the statement is true automatically. So it might be easier to see this if I just do sort of a quick truth table. So we already did this one. So it's only false in the second row. But if I do Q implies P, then it's going to be true in the first row, it's going to be true in the second row, it's going to be false in the third row, and true in the second row, or the fourth row, sorry. So they have different truth values depending on the truth assignments of P and Q. So that means that they're different. If they have different truth tables, then they're different. But the implication Q implies P, so Q implies P, it does have a name. It's called the converse of the implication P implies Q. So could the truth values of an implication and its converse be the same? Yeah, sometimes. Not the whole table, but some of the values. So when P and Q have the same truth values, so if we look at when they're both true or when they're both false, you can see that these were the same. Okay, so when they have the same truth values, P implies Q and Q implies P are both true. Okay, but obviously they can have different as well. And that's why they're different. Okay, so as we've seen, okay, so we saw that in the table. So I'm just going to leave that. The other sort of implication one that I mentioned in the first video, the introduction, is this biconditional. So that's written P with arrows both ways, Q. So you read it as P if and only if Q. So what this is defined as is P implies Q and Q implies P. Okay, so that means I need both of these things to be true because of the and, which we know is going to happen when P and Q have the same truth values. Okay, so this will be true when both P implies Q is true and Q implies P is true. So that means they have the same truth values, and in fact they're true, and this happens when P and Q have the same truth value. Okay, it could be true, it could be false, as long as it's the same. So the truth table for this true, true, false, false, true, false, true, false. So you could break it down. We already did these, so I'm going to go through this pretty quickly. So we know this one is only false in row 2 when P is true and Q is false. This one is only false in row 3 when Q is true but P is false. So then if we AND them together, which is the same as the biconditional, so P if and only if Q, I'm just going to write i.e. P implies Q and Q implies P. So this is going to be true when both of those are true. So that's here and here, but it's false in both of these spots. Okay, and then my note is the same as that I already wrote. P if and only if Q is true exactly when P and Q have the same truth values. So that is the implication and the biconditional.